Hello, and thank you for coming to my presentation. I hope to make this interesting. A warning, this is a more theoretical presentation in linguistics than I've seen by other people. The topic is responding to Benacerraf, could have been using Benacerraf, and developing Michael Devitt's Causal Historic Theory of Designation. So, I'm from CUNY the Graduate Center and a third-year PhD student. All right, let's get into it. So the Causal Historic Theory of Designation was developed by two people, notably, though I will include one more later, Saul Kripke on the right in this photo and Michael Devitt on the left. Michael Devitt was my teacher, and I made this presentation on the basis of developing some ideas that I had, which I turned into a final paper for his class last spring. But anyway, the causal historic view is the thesis. I'm distilling the thesis to a main thesis that language is a to-be-discovered externality. It is outside of us, but it is also made by us. A consequence of this view is that how terms in language connect us to the world depends on the causal historic origins of the terms. I have here an image of a large tree to try to show this idea that languages naturally grow out of their origins. So you can use that as an idea to come back to. As opposed to this view, there's Limitivism, which I append to Noam Chomsky as well as Paul Piotrowski. The main thesis is that language is a biological mechanism coming from within the human animal. A consequence of this view is that, well, so how language connects to the world is as diverse as the diversity of internal mechanisms for producing language in human animals. Here I have an image of the internal brain, since a large amount of people in cognitive linguistics tend to think that that internal mechanism is realized by something in the brain. All right, so now we have this dilemma that I would like to put forward. I'm going to talk about it a little bit elliptically by talking about how we are situated in the world. But this is a meta-linguistic dilemma. It's between radically metaphysically divergent theories of language that we're facing. On the one hand, it seems that language is a totality of activity beyond our singular comprehension. My theory of language meaning is probably quite idiosyncratic, and we can say this is generally true of most people. On the other hand, we seem to get along well enough in the world, and some of us have been capable of designing increasingly encapsulating technology to make encapsulated domains algorithmically navigable, greatly reducing our need to complete the tasks we can export to our computer creations, most of which we buy rather than make. But Chomsky and Devitt, these theorists believe that they're radically opposed, and they both expect our ignorance of the nature of language and attempt to persuade us that it's on the basis of their views that we are ignorant. The biggest difference is that Devitt identifies the nature with humans in a broader sense, a broader metaphysical sense, humans in their environment, with the continuity of spatiotemporal time slices. We can call this growing block view of language the causal nexus. Meanwhile, Chomsky identifies the nature of language with a cognitive electrochemical process internal to the organism, productive of language. It seems we have a problem. In what follows, I will show how, through our considerations of abstract objects and mathematical objects in particular, this meta-linguistic theoretical dilemma can be fruitfully resolved. But first, a word more on theories of reference in linguistics with regards to the specific question, granted that we are able to actually refer to things with words, what guarantees this ability? Descriptivism, which I note that descriptivism of the kind Russell articulates bears a resemblance to the structuralism of Saussure, but I mean to refer to a kind of scientific reduction and logical analysis tradition stemming from Russell and Frege. Modern descriptivism is also not prescriptive. Modern descriptivism is also not a theory, but a data set. So, descriptivism in the Russell sense. To successfully refer, one must provide the necessary and sufficient descriptions for the terms. Reference is a matter of knowing the right definitions. Eliminativism, as I say, Chomsky and Piotrowski, who spoke earlier today, answers this question that in the following way. Successful reference by language is actually a hoax. We may be able to refer, but the study of language does not help us here. Meaning in language doesn't have a reference component. Language is generated by a natural process within the human animal. Talk of linguistic reference is actually disguised talk about language production. Causal Historicism, which identify with Kripke and Devitt, they say successful designation, their term for reference, is accomplished by the term appropriately connecting the user of the term to the objects in the world the terms refer to. And if the object isn't present, then successful reference is about being appropriately situated in the causal nexus. Now, descriptivism, I'm talking about as a way to move to causal historicism. I will not be talking more about the merits of the theory or how it works. I take it that many people are familiar already with descriptivism in the history of linguistics. This was a popular view of philosophy of linguistics for some time. One of the major contributors to the fall of descriptivism was Kripke, in particular in his book Naming and Necessity, 1970. One person who heard these lectures, they were lectures before a book, was my professor Michael Devitt. And within a few years, this topic became Devitt's dissertation. His dissertation is The Semantics of Proper Names, a Causal Theory, 1972. Two main problems that Kripke outlines and Devitt expanded on for descriptivism are briefly ignorance and error. Most people would be in error about what they're referring to, since most people cannot provide definitions for their terms. Another issue is the issue of circularity of terms or weird structures. Even if you could list out the definitions for your terms, each definition will require many more terms, each either continuing until a dead end or involving circularity. In the case where we end up circling for parts of the structure or the whole structure, it seems reference is radically indeterminate. Furthermore, how do we ever escape the terms? So, descriptivism's problem, historicism's solution. I note, by historicism, I mean to refer to the causal historic initial idea of Kripke and Devitt's development of those ideas. The exact criticism of Russell, however, is due to Keith Donnellan. It's due to him that definite descriptions in Russell's theory ought to be divided into attributive and referential descriptions. Referential descriptions then become designations. So to account for ignorance and error, Devitt insists that an adequate theory must allow people to refer even when they cannot provide definitions, i.e., even when they are ignorant. Furthermore, rather than being an indeterminate of an indeterminate. Furthermore, rather than being in indeterminate origin for which terms refer, as the descriptivists must deal with, there will be determinate origins. The work of Devitt then aims to articulate how we can fix a determinate origin for proper names in 1972 with his dissertation, then for singular terms in 74, and then finally designation generally in 81. And I note that though I end this brief historical view at 81, Devitt is still very active. And I was just reading one of his, a book that was published earlier this month called Overlooking Conventions. It's basically against forms of contextualism in philosophy of language. I don't think I would have any issues with that given my development that I make of his theory. Though I note that he might not be the happiest with my attempts, as he once said, it is possibly hopeless or trivial that we are able to refer to abstract objects. But that did not discourage me, and here we are. So let's turn to the question of numbers. It's a subspecies of language. So our language about mathematics, is that abstract or is it natural? Is there a difference? Well, first let's consider counting. Is this abstract or is it natural? Humans count in various ways. And, well, here's a thesis. The various ways all have the feature of referring to the natural numbers. All the different ways that various humans count has the feature of referring to the natural numbers. Now, I'm assuming certain features of the systems of counting that people are going to be using. But at the very least, we can say that countable sets form the foundation of discrete mathematics. And countability, we will see, is a very important feature for determining naturalness. However, let's consider uncountable. Is uncountable in the language of mathematics natural or abstract? The limit of the countable, can we call that the uncountable? Yes, but strictly speaking, there will be cardinalities of uncountable sets, larger and smaller than each other. We will need terms for larger and smaller sets of infinity, which we can use ordinals to designate or to refer to. This world of many infinities is called Cantor's paradise. In the picture on the right here, the jump between the countable and the uncountable happens between the rational and the irrational numbers. So n, z, and q are all countably infinite, where AR forms the first break into the uncountably infinite. Now you may ask, is there a size between the countable and the uncountable? That there is called the continuum hypothesis. It's been shown that Zermelo-Franco set theory is consistent with and with the negation of the continuum hypothesis. So it seems that the hypothesis of the continuum is independent of our standard set theory. Next, let's consider Benacerraf's contribution to our current endeavor. Benacerraf presents a kind of particular problem for mathematical realism of the Platonic type. In the image here, I'm showing the Platonic metaphysics as a mathematical world, a natural world, and a Platonic world, all mutually informing one another. I will note that the Platonic world is not supposed to change, and so perhaps the arrows going to the Platonic do not occur. Benacerraf's identification problem cuts this connection between the mathematical and the Platonic, and shows how we can move on to the view on the right of the mathematical and natural being the only things that we need to correspond. So Benacerraf's problem continued a little bit about it. First of all, Benacerraf is a student of Hilary Putnam, and he shows why numbers cannot be identical to Platonic objects, since we can refer to many numbers countably as well as uncountably many, i.e. transfinite, using either von Neumann or Zermelo set notation. I note that Benacerraf is a student of Hilary Putnam because Putnam is well known for creating what are called push-through constructions, which allow for somebody to construct an isomorphic model to a model that already exists, which is labeled differently, essentially. So Benacerraf's problem you can think of as a subspecies of Putnam's arguments. In any case, consider the two different methods for defining the natural numbers. And just notice that they look different. 0 looks the same, 1 looks the same, but beginning at 2, the rendition of the ordinals on the right relative to the natural numbers on the left can be discerned. There's a discernible difference. Benacerraf's contention is that since the Platonic world is supposed to be unchanging, and it seems we can refer to the mathematical world using either of two formalizations, the numbers must be non-identical to Platonic objects. Now, theories of reference in mathematics. We present this slide to accompany the theories of reference in linguistics, because we have to coordinate the theories. Platonism is a view that mathematical objects exist in Plato's heaven. They're fixed, to be discovered, abstract objects as opposed to concrete. Now, Benacerraf showed how we should reject this, specifically reject that numbers are identical to Platonic objects. Now this leaves us with two other main theories of reference in mathematics. There's Constructivism, which is a bottom-up approach, not assuming mathematical structure is already there to be discovered, and constructivists promote creativity and invention in mathematics. Kit Fine at NYU is my example of a constructivist. Now this view of constructivism makes a lot of sense given there are many kinds of set theory. We talked about Zermelo-Fraenkel set theory with the axiom of choice and mentioned von Neumann in von Neumann's set theory, but von Neumann, Bernays, Gödel also have a more expanded set theory. Morse-Kelly has a set theory, Tarski, Grothendieck has a set theory, and the Morse-Kelly and Tarski, Grothendieck set theories, these are more powerful than the first two mentioned here, but constructivism provides a justification for the many kinds of set theory that have a claim to legitimacy as foundational theories of mathematics. The final theory of mathematics is indeterminacy. And this is actually the orthodox view in current high-level mathematics, at least I'm told, in a 2018 model theory book. In that same book, they show how model theory can help us use the concept of isomorphisms to combat indeterminacy by precisely thinking of identity conditions for models. We will not be doing that today and in this lecture, but I want to point that out. Now, historicism and attributive versus referential descriptions. We are going to return to the insight of Donnellan. In order for numbers to be the kinds of thing we can designate, we must first get clear on the difference between attributive and referential descriptions. Here are two examples, courtesy of David. The attributive description goes, let's call the heaviest fish in the sea Oscar. The referential description goes, let's call that huge fish we saw yesterday Oscar. The only thing that differentiates these two sentences is that the referential description seems to presuppose that we saw a fish yesterday. So it makes reference to the world, whereas the attributive description can be stated regardless of the situation in the world. I say regardless, but there must be an ocean, there must be fish, etc. Moving on. So now, from a historicist perspective, that's a causal historic theory of reference, I contend that this theory is a support to constructivism, the theory of reference in mathematics. Now, our referential descriptions, which are our designation features in the historicism theory or the causal historic theory, does that support structuralism, or do those referential descriptions support constructivism? My main contention with structuralism is for its similarity to Platonism. Only in structuralism, the shadow structures of structuralist theory are built into everything in the world and everything that could be in the world. Thus, for now, I raise this possibility that Donnellan's distinction supports structuralism as the natural mathematical theory to combine with historicism in favor of constructivism or indeterminacy. This narrows the scope of the problem to showing why the dominant view in mathematics, indeterminacy, is compatible with the constructivist genealogy of language generally. Specifically, we can rely on historicism to posit designation chains linking later uses of constructions to some mathematical language, to the first constructions. If it is indeterminate what the similarity and difference between two mathematical constructions is, further inquiry may resolve such indeterminacy. Does this theory, this marriage of historicism with constructivism, cause problems for historicism? I contend no. It does not require any new tools, just a little education. So to help the historicists tackle the world of mathematics, I suggest they use basic model theory to distinguish standard and non-standard mathematical constructions. Briefly on standard and non-standard in math. Most people who don't know anything about math believe that mathematics is a singular language. This is like thinking natural languages all come from and stem from one place. It might be right, it might be wrong. But my primary idea is that if historicism can follow the genealogy of particular mathematical language developments, then they will have the tools to sort out genuinely referential, call this constitutive when considering mathematical objects, descriptions from mere attributions. To grasp this difference is to grasp the difference between heaven and earth. There are two very different standard worlds in mathematics. In mathematics, Earth contains all and only what can be understood through a minimality condition on construction of the mathematical objects. Such a minimality constraint constructs a model which is the initial segment of any future model. Mathematical objects which are constituted in this way we call Earth, because we can construct these objects and because of the way primitive recursion parallels natural rule-following behavior. Specifically, the initial recursive definitions of arithmetic in its various formulations constitute the mathematical ground, or Earth. To quote Haim Gaffman, if a given model is non-standard, then it will be revealed by a proper initial segment that is closed under the successor function. Formally, the characterization is expressed by the inductive schema. You can see it here, where the n taking some variable stands for x is a natural number, and where p taking some argument stands for any predicate. Any well-formed formula of the language we are using can be substituted for p. In this context, the fully constructible universe is capable of being precisely formulated when we loosen the constraint of what can fall within the p argument. Yet, in loosening that constraint, we enter Cantor's heaven. We move from the countable to the uncountable. Again, to quote Gaffman, any non-vague predicate in whatever language can be substituted in P in 1. And we assume here that either the substitution involves no category mistake or that category mistakes are treated as false by definition, so that the antecedent in 1 becomes false and the whole condition true. We can move to a further constraint. We consider heaven set theory and the maximality requirement. From taking the inductive schema as open, one can see the way in which set theoretic constructions of all sets of natural numbers involves a maximality constraint, as opposed to the arithmetic construction minimality constraint. Gaffman puts it in 3 here. Any non-vague predicate P in whatever language determines a set whose members are all the numbers satisfying P. This is a very broad scheme. Following an inductive scheme like 3 for sets and restricting oneself to the ordered class of all ordinals, those are those ranks of infinity, yields the constructible universe, the typo there. However, most subsets of all of set theory are not constructible, and thus 3 does not secure the concept of all subsets, call them A, in the way that 1 secures the concept of natural number sequence. Most importantly, however, is that we took a leap in our construction of mathematical objects to either invoke the cardinality of the power set, this is the Cantorian way of constructing uncountable objects, or to devise other theorems, such as the axiom of choice or the axiom of infinity, which we adjoin to the initial segment for the natural numbers, and then reason about what follows. So there might be a way from heaven to earth or earth to heaven. These are the initial steps. Heaven and earth are merely a gloss of the strategy. Within the field of model theory, and thus the foundation of mathematical reference, it is an open question whether the totality of all subsets of omega is or is not a univocal concept. I'm of the opinion that omega varies significantly enough that the totality of all subsets does not form a universal concept. We've already seen evidence of this given the varieties of set theory which vary in strength, many of which are capable of stating things about the totality of all subsets, as well as more things. The point for the historicist is it is conceptually possible to adopt the constructivist semantics for mathematical languages and then to securely refer to objects which are constructible, while labeling those which are not constructible attributive descriptions in mathematics. Importantly, labeling a linguistic string in attributive description does not mean no reference, however. Rather, it means that there is still an open question to investigate. It does not mean that the model of the language in question will be indeterminate forever. Now, I want to briefly mention non-deactic mathematical constructions as the thing that we should focus on. An important and obvious objection to this theoretical move is to claim that the minimal recursive models for earthly constructions all are a subspecies of deictic uses of words. Deesis is the use of general words and phrases, here, there, that, which secure reference by connecting a speaker at a time to a place. One might claim that these are non-multiply instantiable phenomena. And if we conceive of mathematical object constitution on this basis, it will lead to indeterminacy or relativity. The solution to this problem is to realize that non-deictic attributive descriptions can define, in the minimal initial recursive model conception of natural number, away further fragments of the model, such that those developments do not violate or contradict what has come before. For example, first-order logic was proven to be complete by Gödel. So induction on the complexity of formulas for first-order logic requires only natural earthly objects. The main idea, then, is there are genuinely referential attributive descriptions which do not designate on the basis of standing in designational relations to a speaker's use of deictic language. Rather, these descriptions encode both the language and the theory about the language, using something like the Gödel number for any formula, and show that there is no divergence between syntax and semantics. Now we're in the place where we can update our model in light of the upper and lower bounds in the earth and the heaven, as I'm calling them, of mathematics. Donnellan's distinction takes us from this natural mathematical correspondence, which we got to from Benacerraf, and updates us to get to this world, where the natural world has correspondences to minimal recursive structures and possibly to maximal structures. However, some of our considerations regarding what it would take to identify natural structures, which are natural structures with maximal structures, lead to the idea that we should not consider as natural constructions which admit of many infinities or that are beyond demonstration. Now, but it still remains a matter of investigation among model theoreticians and model theory to discuss the relationship between minimal recursive structures and maximal structures. So, with this all in mind, we can resolve the dilemma that we began with and say that Devitt and Chomsky can be friends. I started this presentation introducing two seemingly contradictory theories of reference. Devitt, who, following Kripke, is convinced that successful use of language connects us to the world quite literally via designation. And I contrasted this with Chomsky, who believes that the whole project of determining what linguistic features connect us to the world in virtue of is a category mistake. Observable language is simply the product of the biological mechanism inside the organism. Yet, if the causal historic theory ventures into the many mathematical worlds, I hope to have provided the initial impetus and theoretical tools to articulate in what way both theorists must rely on one another in the world of algebra. A mathematical object which is non-deactically demonstrated is a mental construction, and Chomskyans will aim to determine the neurological, electrochemical, and the computational basis for the ability. This requires a thesis about an object which contributes to the causal nexus, an object which can therefore be designated. Thus, for the class of skilled mental constructions, namely those following recursive rules, finitely denumerable, and possibly uncountable, more model theory will be required at this point, it will be possible to designate those objects using Chomskyan terms. Thank you very much.